Imagine a machine suspended in the freezing, absolute silence of deep space, 1.5 million kilometers from Earth. It is a silent sentinel, a dark detective drifting in the shadow of our world. Its name is Euclid. For years, this machine's sole purpose has been to hunt the invisible, to trace the ghostly contours of dark matter and decode the mysterious force of dark energy that is tearing our universe apart. But on a quiet day in March, the architects of this digital eye decided to do something unprecedented. They commanded Euclid to pause its cosmic survey. They ordered it to turn its gaze inward, directly into the blinding, chaotic heart of our own galaxy, the galactic bulge. The result is not just a photograph. It is a monumental blueprint of the cosmos. A staggering, hyper-detailed mosaic containing over 60 million individual stars, captured in a single, continuous 26-hour exposure. To the human eye, the center of the Milky Way is an impenetrable, glowing fog of dust and overlapping starlight. Our ground-based telescopes are easily blinded by the sheer density of this stellar metropolis. If you attempted to map this region with Earth's most powerful observatories, it would take thousands of hours of painstaking, pixelated assembly. But Euclid's advanced visible light camera possesses a terrifying level of precision. It did not get blinded. Instead, like a high-frequency scanner cutting through digital noise, it separated the light of 60 million individual suns, rendering each one as a distinct, razor-sharp coordinate on a cosmic grid. Look closely at this map, and the romantic distance of the night sky vanishes. It begins to look like a massive, glowing motherboard. A neural network of a supercomputer spanning light years. Every pinprick of light is a data stream. Every star is a sun, and orbiting many of those suns are worlds we have never seen. But why construct such a massive, overwhelming ledger of stars? The answer lies in the hunt for the unseen. Deep within this crowded stellar jungle, astronomers are searching for cosmic anomalies using a technique known as gravitational microlensing. When a massive object, perhaps a wandering rogue planet, an icy giant, or a silent, isolated stellar mass black hole, drifts in front of a distant background star, its gravity acts as a natural magnifying glass. It warps the fabric of spacetime, bending and intensifying the light of the star behind it. For a brief moment, a star on Euclid's map will flare up, a tiny quantum whisper indicating that something invisible has just passed through the dark. By mapping 60 million stars with absolute, pristine clarity, Euclid has created the ultimate coordinate system. It has laid down the foundational matrix for NASA's upcoming Nancy Grace Roman Space Telescope, which will soon monitor this exact crowded corridor of space. Together, these machines will hunt for rogue worlds, planets that have been cast out of their solar systems, drifting forever in the cold, neon-lit dark of the interstellar void. This 60 million star map is a masterpiece of modern cybernetics, but it is also a humbling reminder. This breathtaking portrait of our galactic core represents only a fraction of what Euclid is destined to capture. As the telescope returns to its silent vigil, scanning the deepest, darkest corners of the cosmos, it continues to assemble a three-dimensional atlas of the universe. We are living in the era of the great cosmic decryption. The stars are no longer just distant myths, they are coordinates, data points, and potential destinations. And as our machines peer deeper into the dark, we are finally beginning to read the code of the universe.